So, 3.2, polynomial functions of higher degree. So anything over a square function. Okay, because what's a square function if it's polynomial? What type of function?
That's x squared in the beginning?
If it's x squared at the beginning, yes, what is it?
I'm the goat.
A parabola, which is a quadratic function. Okay. Graph of a polynomial function is always continuous. Okay? This is a polynomial function. It's smooth and it continues forever in both directions. Okay? This is a polynomial function. This is not a polynomial function. Why? Because it's
not even connected.
Yeah, because it doesn't even connect. It has to break it. It's a
It's yin yang.
piecewise function. It's a piecewise
Yin
function.
and yang.
This is a polynomial function. It's smooth and continually connected.
But that one's not because it has a little point.
Yes.
It's like a camera.
This one is not because it has a specific turning point. It has a vertex. Okay, boom, a specific turning point. So this is a piecewise function. Linear functions are not polynomial, and this would be an absolute value function, and they are not polynomial. Everything else is a polynomial function.
Great.
Okay?
What about that thingamajig?
What thingamajig?
That McDonald's thing. Right
That's
next
a polynomial function.
Because it's moving on the
Because it's smooth and it goes, yeah. Okay, this is the parent function of a cubic function. F of x equals x cubed, okay? Domain of a cubic function is always negative infinity to positive infinity. Range of a cubic function is negative infinity to positive infinity. This is the easiest function to remember. The intercept in this case is 0, 0. That's the only thing that could change on this. And it increases and decreases negative infinity to positive infinity.
I love it.
Okay, this, and this will not change on any cubic function. Only this does.
I have a question.
Yes, sir.
I have one good question and one stupid. Forgot the good. So I'm gonna just ask stupid.
Okay.
Is infinity like actually like counted as a real number?
Yeah, because you can go forever. So, yeah.
That's all I wanted to know.
So the parent function looks like this, that curves up this way and it curves down this way. So it's almost like a snake figure, okay? So we're going to graph all of these three things by hand.
Oh,
I know.
I'm so unsophisticated.
We're gonna graph them by hand and compare them to the parent function. So I'm gonna put the parent function up here first in black. It simply goes like this. Okay. Then I'm going to use green to do this function here. So if I have g of x equals negative x cubed, what's going to change compared to that parent function?
It's just gonna flip the other way.
Yeah, it's going to reflect over the axes. Okay, it's reflecting over. So instead of going this way and this way, it's simply going to come here
Whoa.
and here.
Whoa.
Okay, it flips it. Okay, so in words, I would just say that it flips over y equals x axes.
Then that first one in the left column isn't right. Wait.
Get it, Talia R again.
You mean like this? It should go like this.
Yeah, huh.
Dang.
A little attitude.
I was just saying,
I think you should mark a card for it.
Like this. Yes, you're right. You're right. It should go like this. It flips like this.
It's like because they have to be
Talk
ill.
to me.
Yeah.
I'm like
You're right.
that.
I can cuss them out. No, I don't.
No, I was gonna say.
It goes. No, it's not an M. It's an X. Kind. It comes like this.
That's what Dad's always threatened, but didn't do it.
It flips over. Okay, it flips over. Because it's reflecting over the line y equals x, which is an axis that goes this way.
Isn't that the Z? X, Y, doesn't that the Z axis?
Kind of, yes, it is. Okay, so it's reflecting over that.
I just started
Okay,
walking fast.
what do I do here with the graph in red? How is that going to be compared to the parent function? What, in
It's
words
gonna
first? It's going to
Gonna
shift what?
shift one to the right.
One,
To the left.
left. Is it up, right, left?
Left.
Yeah, Calvin.
Calvin's right.
It's up.
Oh.
That's what I meant.
That's why I said
It
yes.
shifts one up. So this shifts up, okay, because it's not in parentheses with the x, correct? Okay, and it comes here, which means it's also going to
Yeah, Calvin.
fold through right here.
Oh, yes.
Okay, so it flips, it shifts one up. Okay, what about the blue function?
Blue.
One,
Right.
right. This shifts over one right, and it's gonna come like
Yeah,
this.
I think we've learned everything we can possibly learn, and we should be heading towards next.
Okay. So you're gonna have to do a bunch of those tonight, shift them, and tell me in words what's going on. Okay? You can do them all on one graph, just color code them for me. Okay?
Okay.
Okay. Next, page 256 is something you're going to need to take a look at. Because on page 256, you have the leading coefficient test, which we've talked about in behaviors before. We did it in Algebra 2.
Yes.
It's leading coefficient test on here is also known as the end behaviors. When we take a look. So when I know the end behaviors, I know what my graph should look like. Which means I plug in points
And you
until
don't
it
have to
looks
graph
like that.
Oh.
It helps me out a little bit. When the power is odd, when the number is odd, the power is odd, you either get something that looks like an N, okay?
And for.
So odd, you get something that looks like an N, like this,
Really?
or you get something that looks like a W, okay? Something that can look like a W. Now, that's when the power is odd and the leading coefficient, this is when the leading coefficient is positive. That's when the leading coefficient is also, when that one's negative. So W when it's negative, positive when it's an N. When you have an even power, okay, an even power, when N is even, okay, you're gonna get something that looks like, well,
Don't come this way, no sir, go the other way.
Yeah, let's get John out past there.
you're gonna get one that looks like, a backwards, I can't draw it in, so it faces the other way. And then you're gonna get something that's kind of like a M, basically, with your turning points, okay? You need to pay attention to page 256, because you need to know those. Here's the deal, if you don't know what your graph is going to look like when you go to sketch it, you could spend too long doing that. Okay, because you could keep
I
plugging
think
in
that
numbers
happened to me last year.
on the side that you don't need, probably.
Me, I think that happened to me last year.
So you need to know what those in behaviors look like.
Yeah, we're jumping.
Okay, so on A, B, and C, we're gonna talk about what they look like just by looking at the graph,
Which
okay?
A, B, and C?
I was gonna have two turns.
The black ones, the ones in black. So f of x equals x cubed minus x squared minus 2x. That leading coefficient, is it positive or negative?
Positive.
Positive, and is the power odd or even?
Odd.
So what type of graph am I going to get?
Weird looking
Oh,
dog.
wow, wow, wow.
Mm-mm.
A boop boop boop?
One that ends going up.
Would it be that,
Oh,
It's
positive.
the end.
up and
Yeah,
down?
the end.
It's
This
the
actually
end.
gets me.
It's the n.
The fake looking
It's
end.
the n,
Because it
yes.
only has three curves, I mean, two
It's what's the
turns
subject?
since
Correct.
it's power.
So it's gonna be something that looks like the n, okay? Because it's an odd power and it's a positive coefficient. What about negative 2x to the fourth plus 2x squared?
Negative coefficient, but positive.
But it's
So it's an upside down W, I mean M.
So it's an
So it's
upside.
even odd?
an upside down M is a.
That's.
That's a
W.
W.
Yeah.
Mhm.
W is for war.
Yep. What about this one here?
It would be odd W.
It's gonna be,
Yeah.
4, wait, 1, 2, 3.
An
Yeah, 4.
odd.
Wait, no, it's gonna be
It could have up to 4 turns, it could have up to 4 turns.
Would be an N or W?
It's an even.
Well,
Well, because it's
those
a,
are like shapes to go by,
Well, yeah,
but it could have up to 4 turns, so it could be an N, it could be a W,
W.
or it could be like a funky looking figure because it has more
I
than
want the snake.
I want the funky looking snake.
Okay, what about this function right here? What about negative x cubed?
That's
plus
an
four?
N.
You think that's an N?
Yeah.
I mean, when you run.
Well,
that's you
well-
can-
Talia, you would be right in the fact that it's supposed to be an N because it has a cube, but this negative
But it's
does
an
what
N.
to it?
Sorry, it's flipped.
So it's the
it's like
even
the
other
opposite.
end.
It's the same thing, it's just an
Oh,
upside
really?
down N.
It's like a
You
weird
know you
looking.
think computers are
What
safe.
about this one with x to the fourth?
That's a W.
Yeah.
Talia, there's other people in the class.
Are you sure?
Okay, let me shut up.
It's a W.
Nobody else talking.
What about the one with x to the
Not
fifth?
wrong.
A positive odd.
What a strong independent.
Come on, y'all.
That's an N.
What's wrong?
That's an N type shape, yes.
Yeah, Tyler.
Good job, Tyler.
There we go.
Okay, now,
Well,
let us find zeros. How do we find zeros of something?
See, this is why I don't like you. Oh, let's sit on you one day.
No, don't say. How do you find zeros of functions? What do you have to do?
Factor.
Factor.
Sorry, I
Factor.
can't talk.
Oh my
Sorry.
What can I factor out of x cubed minus x squared minus 2x?
X.
An x. Factor out an x, and you're left with x squared minus x plus or minus 2, yes?
Yeah.
What multiplies to give you negative 2 adds to give you negative 1?
Oh my goodness.
What? Negative 1 and 1.
No. 2 and negative 1.
Teresa.
How about negative 2 and positive
Same
1?
thing.
So then what are my zeros? There are 3 zeros here.
X equals 0, X equals 2, X equals negative 1.
Yep, so my zeros are x equals 0, 2, negative 1.
Sorry.
How do I factor this one?
Take out a 2x.
Take out a 2x squared. I'm going to take out a negative 2x squared just to make it easier so that the leading coefficient. And then you would get negative 2. Okay. So then what are my zeros here? I factored out a negative 2x, which makes that sign opposite of what it was. How would I figure out what my zeros are here now? Oh wait, I factored out a negative 2, didn't I? That gives me a negative 1, not a negative 2. I'm being silly. So what is this here? X squared minus 1
A perfect.
is what? So I have x plus 1, x minus 1, because it is a difference of squares. So then my zeros are, this one would be 0, yes? This one is negative 1, and that one is
Why do it there, Derek?
okay? Now, how do I do this? You gotta put in some 2 different.
Group it.
You can't group because it's 5.
Oh,
Or you can.
Right, that's the problem, there's 5. It was a good idea, but I am not going to be able to group that well with there being 5, okay?
There was another alternative, but I forgot the
So-
alternative.
Your alternative for this is gonna be real simple.
yeah.
You're gonna plug it in your graphing calculator, and you're gonna use the trace feature to find all your zeros.
Oh,
Go.
Okay.
Wait, can I do that for all of them?
Nope,
Oh.
why not?
if they're factorable, I wanna see your work.
That's
But
so
what
we
can
can
calculate
do
it?
it,
That's
but
what
we
it
just
is.
don't want us
Right,
That's
I mean,
fair.
you can do it, you just won't get full credit, let's put it that
to.
way.
That's fair.
You can do a lot of
Okay.
things, Tyler.
So if I put this in my graphing calculator, graph x to the fifth minus 3x cubed minus x squared minus 4x minus 1, and then you use the trace feature to find all the zeros, so you're gonna kinda round a little, yes? You don't like
Graph.
the trace feature?
Android.
Make sure your window is set correct,
Shut up, Calvin.
which it should be
It's an
okay.
N.
You said all guys.
It's an N, you think? It is a weird looking N. How
This
many,
camera quality is
times does it cross the x-axis, Cameron?
Dang, how'd you type that in so fast, Kim?
Oh, I did that in
How many times does it cross the x-axis?
How many times can a chicken get across the road without getting smacked twice? Not true.
Not bad.
No.
Twice.
Actually, I know, it's exactly 3 times.
Once.
No, it is an N.
It is an N looking figure.
I still
Twice.
don't understand how to tell the shapes by just looking at the equation.
Twice.
You have to memorize that chart. That's on page 256. You need to look at page 256 so that. I would
Don't
just
worry,
set it to
Jenner, I believe in
the
you.
standard view.
Twice.
10, 10, 10s, all
Side dish.
that. It doesn't cross it twice.
You said full meal.
It should cross it 3 times.
Jenner, what are you doing?
Goes up one, it goes down, and it goes up again.
Yeah, it
You know
crosses it
very
3
well
times.
as an
The x-axis?
Yeah.
Mac and cheese.
Oh, because of the last down.
Yes.
Whoops.
Well, I don't even have mac and cheese.
Okay.
It says error.
Yeah, I can't see very well.
What?
Right. Did you set your
All
window
you need
to
is mac and cheese.
standard? No. Minimum is negative 10. Minimum is
Some people
negative
don't.
10. And so then if you press the trace feature, you should tell that it crosses the x-axis approximately at, I have like negative 0.21 or something like that. Okay?
Yes.
Something around there.
Everybody in
Yeah,
So-
negative 0.21, and then
Negative 0.21,
I can't get the other one.
and then it should be something like, ooh.
The
That other
around
one
it.
is dead
Yeah,
even
one
on
like- the one
negative 2.
Yeah.
And then the other one is almost even on positive 2. It's a little over positive 2, yes?
It won't let me get to that.
So if it doesn't let you get to that, you can press second trace, which takes you to calc, and you can press zeros, and it will take you exactly to the zeros,
Okay,
which is like 2.1, I think.
It says invalid in
Okay, I'll look at it. Give me 1 second. So those are your zeros.
messing up.
I don't get it. Do we have to, how do we find the zeros only when they cross stuff? Or like,
When they cross the x-axis, Tyler, stop talking.
My bad.
so 1 is 0.
So whenever that you see it cross, like when I graph this right here, it looks something like this. Yes?
Mhm.
So it crossed here, here, and here. That's what you gotta trace and find. You can use the table, you can use the trace feature, you can use second trace, which is calc, and it will take you to the zeros automatically. You can, any three of those will work.
I didn't get that thing. Like,
Okay, I will have to check your graph after this.
Plug it in right.
The last thing that we need to do is, if they give us zeros, create an equation of those zeros. So if they give us zeros of -half, 3, and 3, how do I create an equation for those
X
zeros?
plus half, X minus 3 squared.
Okay, so I'm gonna just do 2 separate ones because we do have to do what now?
FOIL,
FOIL. So let's start with the easy ones,
right.
okay? So this would give me x squared, this would give me -3x and -3x, so -6x, and then it would give me +9, yes?
Go.
So then, let's do it this way. Now, an easier way to do 1/2, just throwing this out there,
Divide.
would be to say 2x plus 1. Because if you do 2x plus 1 and set equal to 0, you would get 2x equals -1, you would divide by 2 and you get x equals -1/2, yes? You can do it either way. I like doing it this way because then I don't have to deal with a fraction, but that's just me. So then I'm gonna factor from here, so I get 2x cubed, I get
Minus
-6x,
Oh.
-12x
12, yeah,
squared,
that.
and 18x, right? Then I get x squared, -6x, and
9,
9.
I like
And then I just combine my terms,
it.
so I get 2x cubed, I get -12x, and +x squared is -11x squared. And then I have 18x and -6x, so I get 12x,
Plus 9.
and then +9. And I'm done with that equation, okay? So those are the things that you are working on tonight. Engineer, I will check your calculator in just a second.